Hello class, welcome to lesson 8.1, which is all about monomials and factoring. By the end of this lesson, you should be able to factor monomials and find the greatest common factor of monomials. Okay, so factored form is when a monomial is expressed as the product of prime numbers and variables with no exponents. This is really important, people tend to forget this one, with no exponents greater than 1. So for example, if I said 9b squared, and I wanted you to express that in factored form, that would break down to 3 times 3. Okay, you can only write it with prime numbers times b times b. Okay, so that would be factored form. Now, greatest common factor is if I were to give you the 9b squared, and then I also gave you 27b cubed, and I wanted to know what the greatest common factor between those, I would again write 27b cubed in factored form, and then I would see how many terms they have in common. So I have, some terms that line up. So if I were to write out all of the things that I circled, I would see that my greatest common factor, this is when I can write it, is 9b squared, okay? And if you're confused by that, that's okay, because that's what we're going to go over in this lesson, okay? So if I ask you to factor each monomial completely, that is where I want you to break up your whole numbers to be a product of prime factors. So if I break up 34, this is kind of like if you remember your factorization trees. I know 2 goes into 34 7 times, and those are both prime numbers, so I'm done with that. And then I break up my variables. So I would write it, I have 4 x's, and I have 3 y's, and this would be my factored form, okay? So this is what I would look for. I am not looking for you to write this. I will see people, oops, that should be a 4. I'll see people that will turn in something that looks like this, where they break down the whole number, but then they write the variables as having exponents. I don't want to see that. And sometimes I'll see where people leave the whole number and then break up the variables. Okay? I don't want to see that either. You have to break up every single thing. Okay? Then if we look at negative 52a squared b, I know negative 52 is a product of negative 1 and 52. And then I want to break that up. Whenever you start with a negative, the first step of your factor tree should be negative 1 times that number. And then 2 times 26. 26 is 2 times 13. So I have a negative 1 times 2 times 2 times 13. So I need to rewrite that so that way I have the beginning part of my factorization. 2 times 2 times 13. And then I see I have 2 a's and a b. So this would be my final answer for that example. And then I want to break up 18x squared y cubed. So 18 is the product of 2 times 9. 9 is 3 times 3. Those are all prime factors now. So I have 2 times 3 times 3 times x times x times y times y times y. And that is my final answer, okay? Why don't you go ahead and try one on your own? Hopefully the answer you got was 3 times 5 times a times a times a times b times b. If you have any questions about that, be sure to ask for some help. Okay, now we practice factoring. Let's practice finding the greatest common factor. So the first thing you need to do is write out what the factorization for each of these is. So 6 breaks up to 2 times 3 times x times y times y times y. And then 18yz breaks up into 2 times 3 times 3 times y times z. So now I go through and I see I have a 2 in both of them. I have a 3 in both of them. I have a y in both of them, and that's everything. So my greatest common factor equals 2 times 3 times y, or 6y. Okay? So that's how we find our greatest common factor. Let's try another one. 11a squared is just 11 times a times b. And 21ab squared is 3 times 7 times a times b. And I don't have any whole numbers in common, but I have an a and I have a b. So my greatest common factor is just a, b. Okay, and then I'm going to try one last, I have 2 more. So 30q cubed r squared t breaks up nicely into, let's see, it'd be 3 times 10. 3 is a prime number. 10 can be divided up into 2 times 5. So I have 2 times 3. That gives me 6. 6 times 5 gives me that 30. And then I have my prime factorization. Then 50 works the same way, except I'm going to do 2 times 5. That's my 10. Times 5 gives me 50. I have 2 q's, an r, and a t. Now I go through and I see what do I have in common. I have a 2, I have a 5, I have a q, I have another q, I have an r, and I have a t. So I have 2 times 5 is 10, q, and I have 2 q's, so I'm going to say q squared, r, because there's only one r, and then t. And that is my greatest common factor. Let's look at the last one before we move on. 27 a squared b can be broken up into 3 times 3 times 3 times a times b. 15ab squared times c is 3 times 5 times a times b times b times c. If you're not factoring these as quickly as I am, that is okay. It's going to take some practice, okay? If you need help with it, be sure to reach out and ask for some help, okay? I'm just trying to go a little faster through this so that way we get through the lesson in a reasonable amount of time, okay? You can always rewind and rewatch. So we have a 3 and a 3. We have an A in common, and we have a B in common. So I know my answer is going to be 3AB for my greatest common factor. Why don't you go ahead and find the greatest common factor of 39x squared y cubed and 26x y to the 4th. Hopefully you ended up with 13x y cubed. If not, be sure to ask for some help. And let's look at our final example for today. What is the greatest possible value? Okay, so greatest possible value, when you see that, you should think greatest common factor, okay? What is the greatest possible value for the widths of 2 rectangles if their areas are 84 square inches and 70 square inches, respectively, and the length and width are whole numbers? So basically what we've been doing this lesson is we've been doing greatest common factor. So you should think, I'm probably going to have to find the greatest common factor between the 2 numbers they're giving me. So if I break up 84, I know that's 2 times 42. 42 becomes 2 times 21, and 21 is 3 times 7. So I know I have 2 times 2 times 3 times 7. And if I break up 70, I know that's 7 times 10, which is 2 times 5. So I'm going to have 2 times 5 times 7. Something I think I forgot to mention earlier is when you write a prime factorization, always write it smallest numbers to larger numbers, and then also, so least to greatest, and then alphabetical order for your variables. Okay, so let's see what we have in common. I see I have a 2 listed in both, and I also have a 7 listed in both. So I know my answer is going to be 2 times 7, which is 14, is my greatest possible value for the width, okay? So 14 would be my answer. Okay, go ahead and try this word problem on your own. Good luck. Hopefully you determined 4 bracelets was the greatest number of bracelets that she can make without having any beads left over. Okay? If you have any questions about this question or anything in this lesson, please be sure to reach out for some help. I'm more than happy to help you. All right? Have a good day.